Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, I'm going to be covering utility scripting. I'm going to build a network, create a couple rules for the reservoir, and then run a simulation, and then do some post-processing using that scripting. All right, so let's go ahead and get started. What I have on the screen here is a HEC ResSim. I'm in the watershed setup module. I'm going to take you through the steps, one step at a time here. So here we go. Go ahead and click File, New Watershed, and then give your watershed a name. I'm going to call this one Video 30. And then select the location where you want that watershed to be created. Select your units, the time zone, and apply, and then just click OK a few times. And the watershed has been created. So it created a directory with the appropriate files and directories for the watershed name. Next, I'm going to zoom in a little bit, and sticking with the watershed setup module, I'm going to click the stream alignment tool, hold down Control, and then start clicking with the left mouse button. And I'm going to continue holding down Control until just before the last click. I'll let go of Control and then give the stream a name. I'm going to go ahead and add a computation point. I'll call that CP1. And then I'll click the reservoir tool, hold down Control, single left click, and then let go of Control, click again. I'll call that reservoir 2, or sorry, reservoir 1. It'll have computation points 2 and 3, and then let's just do one downstream computation point as well. Call that CP4. Okay, next I'm going to go Watershed Configuration Editor, and then here I'm going to go Configuration New. I'll call it Config 1, and then set a time step. Okay, apply. Okay. All right, so that's cool. Let's go ahead and file save watershed and then go over to the reservoir network. The first thing we want to do here is network new, give our network a name, and then configuration. We'll select config 1. That was what the configuration we just saved, and then click new. Here is our network. Let's connect that network by selecting the reach tool here, and then I'll hold down Control, let go of Control, and then click again, and then just accept the reach name, or you can give the reach name a specific name if you want to type that in here. All right, that's fine for me. And then I'm going to go network save. Now I want to define an inflow to my upstream junction here, which will flow down into the reservoir and then be released. So I'm going to select the junction tool, right click, edit junction properties, or what I can do is come up to edit and then junctions and then select that junction, CP1, from this drop down. So we're good. And then select local flow. So I'll just type in inflow at CP1 and then a factor of 1 over here. Make sure you're on the top row when you enter this data. And then click apply and OK. Now we also need to make edits to the reservoir, but before I forget, I want to kind of finish up with the inflow idea. All we did so far was just tell the alternative editor that I need to assign an inflow for this junction. Let's go ahead and actually create those inflows now, and then it'll be all ready to go once we create our alternative. Let's go up to Tools, HEC DSS View, and then here's our HEC DSS View window. I'm going to go File, New, and then I'll just call it Data. I'm creating a DSS file here. The file has been created. Then I'm going to go Data, Manual Entry. So I'm just going to call it Project, Location, Flow, H1. This is going to be for the month of July 2024. So I'll say 01 July 2024 at 100 hours is the first time interval. The units will be in CFS, and then the type will be instantaneous value. All right, I'm going to head over to my Excel file here and just grab the data that I have saved. I'll show you what that data is in just a moment, but right click and then paste the data. Oops, I sometimes have to do this twice. There we go. Paste the data into the values field here. And as you can see, I have the different other fields for date and time already numbered appropriately. And yes, it looks like we go through the final hour of the month. So that looks correct. I'm going to go ahead and click Save, and then select that record that we just created, and then click the Plot button here. So you can just get an idea of what the flows are. It starts at about 2000 CFS, and slowly works its way up to about 3,500 CFS almost, and then back down a little bit. So this is the inflow that we're going to use for the hourly time step inflow data for July 2024. All right, so let's go back and make those edits to the reservoir. So I'll click on the reservoir tool here and then right click, edit reservoir properties. So let's go ahead and start with the reservoir pool. And I was just over in Excel and copied the reservoir pool data onto my clipboard. Now that I'm over in HEC ResSim, I'm going to right click and paste. And here is my data. We have elevation, storage, and acreage. So I'll click apply, and then the plots over here in the right populate. Now over to the dam. I'm going to rename the dam and then give it a top elevation of 1500 because that's what it is based on the pool data that I just entered. And next, let's go ahead and add a controlled outlet. We're going to say that it has 3 gates, and then come over here and paste in the data that I had just copied onto my clipboard over in Excel. And that looks good. Okay, so we have our max capacity release from a gate times 3 gates, and then here's the total, which is the individual gate release times 3, and I will leave all the other settings as they are. I'll go ahead and click apply, and then next go over to the operations tab. First step here is to go operations new, and then this will be the name of the operation set. I'll call it operation set 1, and then OK. I'm just going to keep things simple and use the default zones that ResSim provides me, and then just make a constant top of zone elevation all year long. So 1500 for flood control, we'll go 1480 for conservation, and then for inactive, we'll go with 1400. Fly, and we're good there. What I want to do first is run a simulation without any rules. Then we'll come back, add a few rules, and then lastly, we will add some utility scripting to do some post-processing analysis and gathering data and writing that to an Excel file towards the end of the exercise. So stick with me. Let's move on to the alternative in the simulation without any rules first. So I'm going to go ahead and click OK here. And then let's save the network because we made edits to our reservoir. Now alternative, edit. Here's the alternative editor. I'll go alternative, new. I'll just call this alt 1. OK. And then under the run control tab, that's the first tab that it should default to. I'm going to select the time step of 1 hour and leave all the other data the same. Then in operations, I'll select my operation set 1 for my one and only reservoir in the network. And then for the look back period, I will select the look back elevation will be 1480 because that's the guide curve elevation. And then as for the release, I will say it is 2000 CFS because that is the starting inflow. Okay. And time series. Here's the last step we need to do to create an alternative for this exercise. I'm going to select that inflow at CP1. Here's the record. It's selected. Now I go down here and click this select DSS path button. Navigate to that .dss file we created earlier. Here it is, data.dss. Click open and then click this record. Select our time series and then click the button set path name. So that gets assigned over in our alternative. Alternative, save, and then I will close that. Our alternative is saved and ready to go. So let's just save the network to be safe and then head over to the simulation module. So here I'm going to go simulation new. I'll just give it a name, sim1. And then for the start date, again, this is the month of July. So I'll say 01 July 2024. And then I'll start it at the 2nd hour. So the look back will actually start at the 1st hour. And then the end of the simulation will be the final hour of the month, which is 2400 hours on the 31st. Next, down below, I'll select my alternative by checking this checkbox and then click OK. Here is my network. It's ready to go here. We have our inflow, we have our reservoir. Let's just go ahead and run the simulation now and then go back and add some rules. Okay, so it appears the simulation ran without any errors. I'm going to right click on the reservoir and then click plot. Our water surface elevation is 1480 for the entire month. That's correct because that's our guide curve elevation. And then down in this bottom plot, we have the flows for the entire month. Here in black is the inflows, and then in green is the releases. So we have an equal inflow and release, and that's why the storage doesn't change. Okay, let's go ahead and add some rules and then take a look at the results and then go ahead and begin the scripting process. So sorry it takes a while to build all the network and get going, but before we can have any scripting and any results that are meaningful and interesting, we kind of have to go through these previous steps. What I want to do first is create two rules. First of all, I want to set a maximum release of 4,000 CFS for the entire month. And as you can look at this plot, that particular rule or constraint, as I like to call them, would never be active because we're going to be using the exact same time series, same reservoir, and everything else. However, I'm also going to add a second constraint, which will be to say that the maximum release on Tuesdays is 80% of the inflow. So what I imagine happening is the release on Tuesday, which I believe is the second or the third. I forgot. It's the second. It's the second, the ninth, the 16th, and so on. It will be 80% of the inflow, and then on Wednesday and perhaps into Thursday, there will be a higher release, specifically that maximum 4,000 CFS to reestablish the guide curve elevation. Okay, so let's go ahead and do that. I'm going to right click on alternative and then go reservoirs. So I'm not creating a new alternative. I'm just going to modify this alternative here in the simulation tab. And what I'm going to do is click on operations tab, right click, add new rule. So the first rule is that 4,000 CFS max. I'm going to go max 4,000. I think that's enough. From the controlled outlet, it'll be a release function rule, correct? We'll say maximum. It'll be based on the date. So it's 4,000 all year long, apply. Pretty simple. And then I'm going to right click, add rule to all zones. Okay, next was the other one, just the Tuesday rule that involved, it's also a function of rule. So add new rule. I'll call this max 80% inflow on Tuesday. So it'll be for the controlled outlet. It will be a release function rule. I'll click OK. Here's maximum. Now what I want to do here is define. It'll be based on the model variable, and that's for the reservoir pool inflow. Click select, OK. Now what I need to do in this table here is tell ResSim that the release is going to be 80% of the flow. So my first record is trivial. I'll just say 0 and 0. And then I'll just create a second point to create a line between these 2 points and use numbers that are larger than I would ever use. So I'll say 100,000. If it's 100,000, the release would be 80% of that, which is 80,000. So 80,000. Okay, so that is almost done. I'm going to click apply. The last thing we need to do is go to this day of week multiplier. And what I'm going to do here is change it so that it's a large number except for Tuesday. I'll just set it to 100 except for Tuesday where it'll be 1. So that should work there. And I think we're good. So it really only applies to Tuesday. And let's also right click, add rule to all zones, and then apply. All right. So let's go ahead and run the simulation and see how these two rules affect the releases and of course the water surface elevation. So I'll hit compute alt 1 and then close. Let's right click and take a look at the plot. Okay, I'm going to go full screen here and looks good. Let me go ahead and zoom in a little bit now, just the first couple weeks. So it looks like Tuesday is the second. On this bottom plot, we have the inflow, which we had seen before. That didn't change. And then the outflow or the release from the reservoir is, yeah, you can see the green line is the release, and that's about 80% of the black line. And that a rule only applied to Tuesday. And then again on this Tuesday over here, it doesn't look like 80% on this plot, but that's just because the scale starts at like 1800 or something. It's not scaled down to 0. And then on Wednesday, we see for like the first half of the day here, the max release is an active constraint, that 4,000 CFS release. And then again on Wednesday the 10th, which is more than half the day, it's probably twice as long there, we're releasing 4,000 CFS until that guide curve elevation is reestablished in the reservoir, in which case inflow and release, again, equal each other. Now we're going to get into the scripting. And what I want to do is build a script, grab the inflows, grab the releases, and then identify when the inflows, which time steps these particular rules are being utilized and governing the release. So if a rule is governing the release, I would call it in optimization terms that a constraint is active. Just so you know what my terminology is sometimes when it slips out of my mouth. All right, let's go ahead and get started here. So I'm going to go ahead and just minimize that because we may want to bring it up later. I'm going to go tools and then let me close this tools and then script editor. Okay, so I've got my simulation tab folder directory selected over here in the left menu. I'm going to create a new script. And then up at the top here, I'm going to give the script a name. I'm going to call it weekly hours max flow. Maybe there's a better name. That's fine. I'll just leave it at that. Okay, it started me off with a few imports. I'm not going to waste a lot of time typing and trying to figure it out. It's already pretty much figured out how to do this exercise. So I'm going to need all of these include statements as well as much more code down below. The first line is to actually identify the DSS file because I need to grab the inflow data and grab the release data from the simulation so that we can use that in our own manipulation logic and then ultimately exporting that data. What I need to do here is grab the file path to our DSS file. So I'm going to go back over to ResSim and then Tools, HEC DSS View. And yes, so here are the results from our simulation. I'm going to go ahead and select the file name up here, which I call a file path, whatever. Copy. It's basically an absolute path from the root directory of my local machine here all the way through the file name. And then I come back to the script editor and then paste that right in here as the first argument as a string. And that looks good. Next, I need to get the release data and the inflow data. So I'm going to call this release path. Then I need to grab the path. So I'm going to go back to DSS view. So this will be reservoir pool and then flow out. So I'm going to just, one easy way to do this is right click, rename, and then it is right here. So I'll just highlight and then Control C to copy. Don't need to do anything else with that right now. And I'm going to paste that string that's on my clipboard right here inside the string. Okay, I'll go release data set equals DSS file dot read and then the data set. Okay, so that is the file reference. We've got the release data set right here. Okay, to save time, I'm just going to paste in the same thing for the inflow data set. The only change here was flow in instead of flow out. And of course, the variables were different named also. All right, next I'm going to paste in some more code. What I'm doing here is converting that data, the release data and the inflow data from its time series math object into a list, which I'm a little more familiar with and comfortable using a generic Python list. So that's just taking the creating the container object and then extracting the values, which is the dot values attribute. So now we have release values, which is a list, 744 records, and inflow values, which is a second list of 744 records, which is the number of hours in a 31-day month of July 2024. Okay, next up, I'm going to get the number of time steps. That's this value here. It's just an integer. So I will type in int. All of this documentation is in the Java docs. So I could have used the inflow data, but release data has the same number of time steps. So we'll use that in our for loop, and we're looping through each record. We know how many loops to make. And then release times. This is this is, again, I could have used the inflow data, but it captures the actual date and time of each time step. So this is a list of dates and times. Okay, I'm going to give myself some more lines here and then paste in the beginning of our loop. Now I haven't written any code inside the loop, but what I am doing is I'm initializing some data here, and you'll see how this is all used. This is the number of hours on Wednesday that active constraint is running for. So we know the active constraint will be invoked or most likely invoked on Tuesday for all 24 hours because it's 80%. That's the second constraint. But for a constraint one or the top rule, 4000 CFS max, that will most likely occur on Wednesday and maybe into Thursday as well. And the number of hours that occurs each week will change. So I'm just creating an empty list. Constraint one and constraint two have lists here as well. These are going to contain values of either 0 or 1 for sort of on or off, true or false. And then I have a list for dates and then times. So the loop is going to step through each time step, 0 through the number of time steps minus 1. So basically 744 times with an starting index of 0. Next we got, let me go ahead and paste some more code in here. Okay, so what I just pasted in was all of this right here. For each step, I'm getting the release and I'm getting the inflow and I'm getting the date and time. I am initializing each constraint to be 0 or inactive, and then I'm going to change it to become active, i.e. equal to 1, if the condition for it being active is met. So the first one is if the release equals 4,000, then I'm going to say condition 1 is met. And then the hours this week is going to be incremented. Hours this week starts at 0 up here. And then if the release is less than 4,000, what we'd have to do is check if hours this week is 0. And then we'd have to check if the hours this week is greater than 0, because if it is, then that means we have to write a record to our hours each week to say how many hours was it active for? How many hours was it releasing 4,000 CFS? So I could probably, instead of hours each week, could probably call it constraint 1 hours this week. And then I reset hours this week equal to 0. Okay. And then this last if statement here is basically, yeah, I had to use a round function, but basically if the release equals 80% of the inflow, that would mean that constraint 2 is active. So I'm setting C2 equal to 1. And then what I'm doing at the end of the loop here is I'm appending that 0 or 1 value of C1 and C2 to the list C1A and C2A. All right, and the last line of code I need to type in here or paste in is a dialog box. So what I'm going to be doing to start off is just printing out the hours each week. This is a list, and I know we haven't displayed the constraint data or the time or anything, but I just want to see the number of hours each week, have it pop up on the screen as a Java dialog box in a list format, and we'll see what that looks like. So I'm going to go ahead and look at the results one more time, predict what the value should be, and then we'll run the utility script and see what it comes up with. So I'm going to go ahead and save without running and then look at this results again. And again, we have 24 hours of 80% the inflow, and then the release is 4,000. So this is probably like 5 or 10 hours. We don't have to guess though. I'll go up to file, tabulate, and that is the second. So the beginning of the third day of the month. The inflow and the release are the same for the first day. And then for the second day of the month, we have the release is going to be about 80% of the flow, of the inflow. So that's those 24 rows. And then on Wednesday, which is the third day of the month, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I could just come over here and count. Yeah, 9. So we should have 9 records or 9 hours where that maximum flow. So the first value in that list should be 9 for 9 hours. And then we go ahead to the next week, which would be the 10th, and we see a few more hours than 9. We have 4,000 listed out all the way until 5 p.m. So that would be 17. So the first 2 records in our list when we run the script should be 9 and then 17 is what I'm expecting to see. But let's go ahead and close that, minimize that, and then run the script. So I'll just go back to the script editor. I can run the script just by clicking this save and test button. And looks like there's an error. Okay, I think I just misspelled something, line 14. So click edit. Oh yeah, I'm sorry. This needs to be here. And then did I make the same mistake here? No, that looks good. Okay, so save and test. And then boom, here are the results. Now it's not too obvious what we're looking at, but hopefully I explained it good enough leading up to this. 9, 17, 22, 15, and 17 are the number of hours on Wednesday that constraint 1 is active, that 4,000 CFS max is active. And we did confirm that the 9 and 17 were correct. So let's just roll with it and assume the other 3 are correct as well. Okay, there's a few more things I want to do because this is not really the final product. This is just kind of an intermediate checkpoint to make sure that we can correctly read the data and manipulate the data a little bit. So I'm going to go back to my script, click edit to enable editing. Then I'm going to go down to the for loop. And at the end of the for loop, I'm going to add some lines and then paste in this code right here. What I want to do is actually display all the data that I'm going to put into the Excel file before I actually do so by printing it to the console log just to make sure that the data looks correct. And the data that I'm retrieving here, I guess I could add some more comments or any comments. But anyway, it is the times. So I'm getting a list for the dates and then also the times. So those were initialized up here with dates and times. The dates is gonna say July 1st for the first 24 records, and then July 2nd for the next 24 records, and so on. And then time is going to be, well, 100 hours, 200 hours, 300 hours, all the way down to 2,400 hours, repeating 31 days for the month. So that's what I'm doing, using the dates list for and the times list for. Down below that, after the dialog box, I guess we'll leave that there for now. I'm going to paste in some printout. What I'm doing here is printing to the console log, and I'm just printing out the number hours each week. We already had that up here. And then C1 list, C2 list for the rules 1 and 2, and then the dates, and then the times. So let's go ahead and open the console log, run the simulation, or I'm sorry, run the script, and then see what that console log looks like to make sure our data is correct. Okay, so I'm going to go ahead and hit save. And then when we test it, let's go ahead and try something different now. Let's go up to Tools, Scripts, and then we can actually just go Add Script, Add to Panel, and then select our script, click Add, and then OK. And then cool. So our button's over here. We can just click this button to run the script now if we want. So let's open up the console log first so we can just do it before and after. I'm going to put the console log here and then zoom down to the bottom. Okay, so any new text in the console log will be below my current position in the console log. I'm going to come over here and click the button here to invoke the script, weekly hours max flow. And that's good. Here's our message box as before, and then I click OK. Now let's check the console log, and yeah, so if I scroll down a little bit, it's starting to print the console log. Here's the hours as before, which is good. And then we have our list for constraint 1 or rule number 1, which shows, yeah, so that is the 4,000 CFS. So there should be 9 ones here representing the first 9 hours of July 3rd. And then I believe 17 was the next number. So there should be 17 ones here. And then I think 22 ones right here representing the first 17 hours of Wednesday the 10th, and then the first 22 hours of Wednesday the 16th, or sorry, 17th. And then CTA2, oops, okay. So this is the second constraint. So we should have, I'm not seeing any number. Oh, there's a 1. 1 second. I fixed the problem. Here's the code that works for the for loop right here. And what it did is it resulted in my C2 constraint, which is the Tuesday constraint, to show up as expected, where I've got ones for the 24 hours of every Tuesday. So there's the first Tuesday, here's the second Tuesday, and then here is the third Tuesday, and so on. So go ahead and pause the video, and this is what I use to get those results. Okay, back to the console log. I printed out the dates. So here are the dates. Again, July 1st for the first 24 hours, and then July 2nd, and so on. And then down below that, it's the times. So we got 1 o'clock, 2 o'clock, 3 o'clock, all the way to 2,400 hours. And then that repeats for each day of the month. All right. So that's good. We're ready to actually create the Excel file now so that we can export that data to Excel. Okay, so I'm back over in the script. I'm going to create and print data to an Excel file is my label here. Got some labels. What I had to do is actually import some modules here. And then workbook was what I'm creating. And then I'm creating a sheet called the results inside the workbook. Okay, next, what I'm doing is I'm printing out the first row, which is going to be the title row, which across the top is going to be step, date, time, inflow, release, and then constraint 1 or rule 1, and then constraint 2 or rule 2. And if it's active, that's what the A stands for, if it's active or not. So the step is just going to go 1 through 744. The date is going to say the day. Time, inflows, and release are going to be the actual inflow and release values in CFS. And then constraint 1 active and constraint 2 active is going to be 0 or 1 based if it's inactive or active respectively. This is how to do it. So I'm looping through the column titles list. And then this 0 here represents the row. So the title row is the first row. It's index 0, but just think of it as the first row, number 1. And then I'm going to set the value to the title. Paste. So what this code does is it actually writes the data for all the rows below the title row. What we did before was create the title row and just print out the string, which represents the value of each column. And then from rows column 1, or actually really row 2, all the way down to what would be 745. What I'm doing in each of these situations is I'm grabbing the value, which and then setting it. So one row at a time, it's working across the columns. Here's the date, here's the time, here's the inflow, here's the release, and then here is the C1 active and C2 active. For each of these columns, I need to create a cell and then set the value of that cell. I'm doing that for each cell, for each row. Okay, the last code that I need to paste in here, I swear this is the last one, guys, is right here. This is the process of creating the Excel file and writing that data we collected in from the workbook to the file. So go ahead and check that out. It's basically contains my file path here and a timestamp. So if I run it multiple times, it's not going to be a conflict with the previous time if I don't delete the file. And then the last line here is going to be a Java dialog box telling me that it's successful. So hopefully it is. Let's go ahead and see what that looks like. I'm going to go ahead and click save without running it. And then I'm going to close. And then let's close that as well. Let me go ahead and open up my watershed directory. So it's right here, video 30. So what I expect to have here is a results.xls, or sorry, results underscore datetime.xls Excel file after running the script. So let's run the script and then return here and see what that Excel file looks like. Okay, run. Okay, so this is just the box from before. And all right, Excel file created successfully. I'm going to click OK. Let's check this out. There it is. Our Excel file is there, 28 kilobytes. It was just created. Yep. And drum roll, please. Let's take a look at what's in the file here. It should be one worksheet. We have one worksheet here. It has the results tab, and we have, let me just center everything. Makes it a little easier to see, I think. And then the date. Yeah, so the step number, the date, the time of day, and then our inflow, which starts at 2000, and then the release, and then the rule number 1 and rule number 2. So let's scroll down, and rule number 2, which is the 80% of inflow, appears to be active for Tuesday, yeah, July 2nd, and that's probably going to be for the entire 24 hours. Yep. And then what we have starting Wednesday, July 3rd, are the ones, these are 9 ones for the first 9 hours of the month of the day, and that's to release the excess storage in the reservoir. And it looks like the 10th hour even does continue to release more than the inflow, but not quite 4,000. So, there's maybe instead of one, it could be like a partial membership. But then on the hour after that, it resumes the match, at least to the nearest full CFS or 10th of the CFS. I could scroll down again and find the next week if we want to just confirm it again. Here is Tuesday, July 9th. We have 24 hours of an active rule governing that release, followed by 17 hours of our first release rule governing the release, which is 4,000 CFS max. So anyway, this was just a utility scripting exercise in HEC ResSim to demonstrate how we can click a button and have lots of other things happen to help us analyze the results of a simulation. And this is important because it can really save time and energy and also help automate results and get results faster.